Hello everybody. Today we are going to talk about solving linear inequalities that are compound inequalities. Okay, there are two kinds. There are or compound inequalities and compound inequalities. For the or, you can see that it's going to look like two rays. Okay, so and you're going to do those parts separately. So for example, this part over here that I just highlighted, you would express that as x is less than or equal to -4. And then the part that I'm going to highlight in the lavender, that part would be expressed as x is greater than 1. And you put the word or in between. So this means the solutions can be in either area. They can be in the area where, in the green or the purple. And then yesterday you learned about interval notation. So the interval notation for this is going to look a little different because you're going to have two parts to it. The green part is going to be starting left to right, -infinity to -4, and we put a bracket on the -4 since it's a closed point. And then you put this like U shape in between, and this means in union with or united with. And then you do the other part of your graph, left to right, which is 1 to +infinity. And on this one, they're both parentheses because there's an open point on 1, and if infinity, positive and negative always have the parentheses. So that's written out in interval notation. To solve the or inequalities, you're going to solve each part separately, then graph, okay? And your graph will be the two rays. Okay, so the first one, solving just like we do an equation, we would subtract 4 from both sides to get 3x plus 0 is less than or equal to 6. Then we would divide both sides by 3 to get x is less than or equal to 2. So that part, and then let's go ahead and solve the other part. And then we would divide both sides by 5 for the other part of our inequality, and we would get x is greater than 7. So because this is an or, we're going to graph two rays. So for the part where x is less than or equal to 2, we are going to put a closed point on 2, because 2 is part of our solution, and we're going to graph to the left. So the solution for x is less than or equal to 2 part of our inequality is that graph or that ray. Our other part is going to be an open point at 7. 7 is not part of our solution. The numbers greater than 7 are our solution. So our ray would go to the right. And then the interval notation, left to right, the green part would be -infinity to 2 with a bracket because 2 is included in union with, and then 7 to +infinity for the purple part, and these are both parentheses because 7 has an open point. Okay, one more example of the ors. You would subtract 7 from both sides to get -9n plus 0 is less than or equal to -9. And then we're going to divide both sides by -9, in which we have to remember we're dividing by a negative to both sides, so we need to switch our sign to a greater than or equal to sign. And then we would get n is greater than or equal to 1. The other part of our graph, we're just going to subtract 6 from both sides of our inequality to get n is less than or equal to -1. So now for the one part, n is greater than or equal to 1. That's going to be a closed point at 1. And then the value's greater than to the right. And then the other part of our graph, n is less than or equal to -1, is going to be a closed point at -1, and then less than is to the left. So there are two rays representing our solutions for this inequality. And then our interval notation, left to right, would be negative infinity to -1, bracket on the -1 because it's a closed point, in union with 2 to positive infinity, bracket on the 2 because it's a closed point, and then parentheses for infinity. So that's our examples of the compound inequalities with or in them. With and, these are the ones where it has to satisfy both parts of the inequality. So our solution is where they overlap. So to write this one, this would be, I'm just going to show you in 2 colors just to show you how this works. So this one would be x is greater than or equal to -2. And then we put and in between instead of or. And the other part is going to be x is less than 5. Because it's and, we don't have rays anymore. We have a line segment because it has to satisfy both of them. So we would erase this end part, and it's where they overlap, like in this area where those two overlap. That is our solution because it has to satisfy both of them because it's an and. So the way you, and there's another way you could write this, you can write it as one inequality like this, putting your boundary numbers, so left to right, in between here. -2 is less than or equal to x is less than 5. So that's a way you can put and compound inequalities together in one inequality. Okay? The interval notation does not have 2 parts when you have an and. It just goes like this, left number, -2, number on the right, 5, and then your parentheses and brackets. Bracket for -2, because it's a closed point, parenthesis for 5, for the open point. So that's interval notation for the and compound inequalities. Now, the solving part. If the and inequality is written out with the word and in it, then you solve each part separately, just like we did with the ors. But if it's condensed like in this form, okay, then you can solve it all together working inside out, and I'll show you what that means. Okay, so first let's do one that's written out with and in between. So we solve this one just like we did the or. So we would subtract 3 from both sides. We'd get 2x is greater than -12. Divide both sides by 2 to get x is less than -6. The other part, add 2 to both sides. We get 8x is less than 32. Divide both sides by 8 to get x is less than 4. All right, we have open points at both of our numbers. So an open point at -6 and an open point at 4. And then our solution is in between because x is greater than -6 and x is less than 4. So the part where it overlaps, where we can say it satisfies this one and this one, are these numbers in between. And then our interval notation, you just do left to right, -6 to 4, and then they both have parentheses because they're open points. Now, when it's condensed like this, you want to get a by itself. So in the middle, you have to get rid of the things that are with the a to get a in the middle by itself so that it looks like that inequality, okay? So what we're going to do here is we are going to add 1. Now, when we add 1, we have to add it on both sides of the inequality too. That's working inside out. So now when we do this, -2 plus 1 is -1, less than or equal to a, and then this is 0, so we just have a is less than or equal to 7. I like this way better because then I think it's so obvious how you graph it. So the values at work are in between -1 and 7 and including -1 and 7 because of the less than or equal to signs. So closed point at -1, closed point at 7, and my values of A that are solutions are everything in between. So there's my solution as a graph, and then an interval notation left to right, -2 to 7, and brackets on both sides because it's a closed point. So that is your interval notation. Now, you can pause the video and try number 5 and 6, okay, and then turn it back on to see if you got them correct. All right, in number 5, it's an OR, so solve each by themselves. And you would get M is greater than 8. And then the one on the left, subtract 7 from both sides. Get -5M is greater than -35. Divide both sides by -5. And you have to flip your sign because you're dividing both sides by a negative. And you get M is less than 7. For M is greater than 8, that's going to be a closed point at 8. Or I'm sorry, open point at 8. And then greater, that's going to be to the right. And then for our other part of our inequality, M is less than 7. That's going to be an open point at 7, and the values that are less than are to the left. And then our interval notation, left to right, -infinity to 7, both parentheses. And then we do our in union with. And then the purple graph, or the purple ray, is going to be 8 to positive infinity. And that's an open point, and so parentheses. And then always parentheses on infinity. So that's an example of OR. And then here's an AND. Okay. So for this one, we're going to work inside out. So just like you'd solve an equation, you'd get rid of the 1 first. So you're going to add 1 on both sides of your inequality. And you're going to get -3 plus 1 is -2, less than or equal to 2x, and that's 0, so just 2x is less than or equal to 6. Then I have to divide everything by 2, inside and outsides, and I get -1 is less than or equal to 1x is less than or equal to 3. So then I'm going to put closed points on both -1 and 3, and my solutions are all the numbers in between and including -1 and 3. So that's my graph, and then my interval notation would just be -1 to 3, both with brackets because there's closed points. -1 and 3 are part of the solution set. Okay, so hopefully that helped you today. You can always watch this again if you need to. There is a practice to do on Canvas, so please do that. Tomorrow in class we will be reviewing for our Unit 0 test. I'll put the review on later today if you want to get started on it. And then sometime this weekend I will make a video of me going through all the review problems just in case you want to go over anything before Monday. Okay, your test will be on Wednesday next week. If you are Group A, it'll be on Tuesday if you are Group B. And you will take your test in class next week. Okay, have a great rest of your day.